They might have a lot more than us. We might still have springtime. We'll be there. I'll be there. All right, my friends. So this is kind of review stuff. Go to the very last page. Go to the very last page. I added a couple of little gym dandies. Go to the last page. That one. All right. So I totally goofed it. I taught this totally incorrect because I'm human and I make mistakes. All right. So let's take a look at this. So this would have been a graph that looked like this. Okay. So let's find the equation. Okay, so watch how easy this is, and you'll see how bad your teacher messed up yesterday, and I apologize. All right, so couple things, all the time. Couple things to recognize. Let's see, -1, 0, and let's make that, as long as this distance right here is a distance of 1 from this point to this point, this will work for you every time. Ready? You're going to be like, dude, stir up, really? You messed up that badly? All right, so I'm going to look at this distance here. How far is that? 3 to -2. How far? 5, right? So eyes up here, this is how easy it is. So this distance from our second point to our asymptote is a distance of 5. So log base 5 so far. Good so far?
Yep.
Did this shift right or left?
Yeah.
Left. How many did it shift left?
1.
2. So look at the asymptote. So I'm going to make this x plus 2. Did it shift up or down?
Yeah.
It shift up 5.
No. Where's that hitting?
Down 1.
It doesn't shift at all. Because right there.
That's it.
So here's my equation. We're
You're a
done.
trickster, Mr. Strip.
All right. That's it.
That's all we
That's
have to
it.
do. That's it.
That's it. All right. Let's take a look at this one. So using the same equation, how far is this? It's a distance of 5, so my b value is 5. So this one will be log base 5. Log base 5. Did that one shift right or left at all?
Right.
Yeah.
It shifted
Right.
right.
So
Look at the asymptote. The asymptote is right on the y-axis.
Oh.
It didn't shift. There's no shift right or left, so I just have x. Did my first point shift up or down? How many?
1.
Close.
2.
1, 2, right? Done. You guys watching? Okay, and again, this one kind of looks like this. Okay, so how far is this distance right here? That's a 6 to a 3. So I have log base 3. Okay, base 3. Did this one shift right or left? It shifted right. Look at the asymptote, so that's going to be x minus 3. Did it shift up or down? Look at our first point. -1. Done.
So this will work for all of them?
As far as what we're working with, yes.
Nice.
So how easy is that? Sorry I goofed that up. It must have been paint thinner I was drinking around the coffee yesterday.
Is it easier to write the equation or to graph it with the
I think it's easier to write the equation off of this. All right. Let's go back to the beginning. So that was off the last page, right? All right, so this is a little bit of review. So let's graph both of these. So we have log base 2 of x. So we'll do this one blue. Okay, so things what we have to know up here. If I plug 0 in, if I take log base whatever of 0, it becomes an error. Okay, if I plugged 1 in, I'd get 0 out. And I'm going to choose to plug 2 in because that's base 2. That'll give me a 1. So my asymptote on my blue is here. Is that okay? Because I didn't add or subtract anything from the grouped x. So group x isn't grouped with anything. So then I have 1 comma 0 here. And 2 comma 1 here. So this is what this one looks like. Okay? That's it. The second equation.
Can we do it on purple?
The second equation, I have to remember a few things. So my asymptote's also going to be here again. Okay? If I plug 0 in, I get an error. Okay? If I plug 1 in, I get 0. And then,
if you put 2.7.
oh wait, that should have been 2.7. Okay? So that should be as much as you would have to go there. So 1 comma 2.7. So this one kind of looks like this. Where that point right there is 2.7 comma 0. Or, oh my gosh, did I really? I really did. I broke it. You guys just can't have nice things anymore. So 1 comma 2.7. So 1 comma 2.7. There we go.
Wait, so you only have 1 point?
Yeah, I could probably put the second if I want to. All right. Yeah, I think we're actually going to finish it today.
Oh yeah.
Well, I got to make sure I do because if we have 2 snow days.
That'd be freaking legendary. Mr. Sorb, if we do, I'll make a group chat with all the people in this class and then we go sledding.
Yes.
Yeah.
All right. So graphing exponentials versus log. Graphing exponentials versus log. I gotta double check something real quick.
Messed up.
I gotta go back here. I messed up. Jeez Louise, I'm telling you. If I plug 1 in, I get 0 out. 1 comma 0 is here. So this basically looks like this as well. Sorry about that, I goofed that up. All right, let's go here. Parent function, y equals b to the x. Parent function of log is y equals log base b of x. Horizontal asymptote is y equals 0. Often that. Vertical asymptote, so that's on exponential. On logarithmic, vertical asymptote, so notice you have vertical asymptote versus horizontal asymptote. So that should take place because they are inverses of each other. Domain for exponential, negative, positive, infinity, where range is 0 to infinity. And look at the domain and range of the logarithmic. They're flip-flopped, so the x, y. And then if I have b raised to the x plus h, it moves left, right. It does not change the domain and range. If I have log base b of x plus h, it often will move right or left. And look at how the domain changes. And then that's about everything we can talk about with these. Some of you are talking too much. All right, for each parent function, identify how the parent graph was changed, identify the asymptote, state the domain and range. So what would my asymptote be here?
-4.
Is it vertical or horizontal?
Vertical.
Vertical, good. So x equals, wait, take it back. X equals 0 on this one. Why is it 0? It's not grouped. The grouping is going to talk about the asymptote. So there would be, this could be x plus 0, x minus 0 grouped. Okay, that's my asymptote. Okay, this also shifts down 4. Okay? So if we were to think about what this graph looked like, it's going to kind of look like this. So my domain on this one will go from 0, rounded bracket, to infinity. My range will go from negative to positive infinity, because the closer I get over here, the more negative my y value becomes. Okay, so the shifting didn't really mess a lot of things up because the whole graph actually shifted down from the parent function. This one is going to have a asymptote at x equals -3. It's opposite of that. So this shifts left 3 because it's grouped, and up 2. And then again the domain. So the domain on this is going to be affected a little bit because I can't have natural log of 0. So I'm going to go from -3, not include -3, to infinity. There's my domain. This affected my domain. My range on this is going to do what? Natural log graph. Natural log graph still looks like this.
Negative infinity to positive.
Yeah, negative to positive infinity. Okay, so natural log and log graphs look very similar to each other. Okay, is that all on that one? Can I move on? Rewrite the equation in logarithmic form. Log base x of 81 is equal to 4. Obviously, this one would have been easier to solve as an exponent if we were to solve it. So if we were to find x, what number to the 4th power gives me 81? So x would have to equal 3 because you take the 4th root of both sides. And just worry about the positive component of it. Okay, this one, if I wanted to write it as a logarithm, I can do this. So that's going to give me log base 3 of 1 over 27 is equal to x. So there's a couple ways we could look at this to solve it. We could try and solve it off of this. We could also realize 27 could move up, make it to -1. So I'd get 3 to the x equals 3 to the -3. So x has to equal -3 on this one. Okay?
2. -2.
It is 2. So this will work. So this would be log base 32 is equal to x equals 1/5. So the 5th root of 32, 2, 4, 8, 16, 32. So x equals 5 here. That'll work. And then e, we're not using log anymore. We're using natural log. So if I do ln of both sides, I'm going to get x equals ln 1. Okay? And natural log of 1 means e to the 0. Yeah, e to the 0 is 1. We doing all right?
Yep.
All right. Rewrite the equation in exponential form, then find x. What base is this right now? 10. So 10 to the x is equal to 0.0001. So that's going to be 10 to the x is equal to tenths, hundredths, thousands, 10,000. So 1 over 10,000,
10 to the -4.
which is 1 over 10 to the 4th. So that means x has to equal -4 because you bring it up good. Number 10, rewrite the exponential form, then find x. So 5 to the negative 3 is equal to x. So that's going to be 1 over 5 to the third. 1 over 5 to the third is 125. So 1 over 125. All right, let's see. 2 raised to the x equals 128. We can think about how can I make 128 base 2. So 2, 4, 8, 16, 32, 64, 128. So 2 to the x equals 2 to the 7th. So x equals 7. Log base x of 81 is equal to 4. So that's going to be x to the 4th is equal to 81. Okay, so what number to the 4th is 81? That would be 3 because 3 times 3 times 3 times 3. You doing all right? All right, so properties of these. I can do log A plus log B. On this one, this is going to be log A minus log B. And this is going to become C log A. Remember all those properties? Remember the exponent comes down front? So that's just some expanding. We doing well? Am I going too fast? Anybody starting to cry?
Yes.
All right. Use log 2 equals A, log 3. Okay, so this can be broken up to log 2 plus log 3 because 2 times 3 is 6. Log 2 is A. Log 3 is B, so A plus B. Log 9 can be broken up into, say, log 3 squared, which is 2 log 3. Log 3, they told us was B, so I have 2 times B. Let's see. This can break up to log 5 minus log 2. They told us log 5 is C. They told us log 2 is A, so C minus A. That's an A. And then on this one, we have to expand it a little bit. So let's see if you're paying attention on this. Log 3 plus log 5 minus log 2. Good. So log 3 is B plus 5 is C, and log 2 is A. So we broke 15 up to 3 times 5, and then we expanded it. Yes?
Yep.
Expand each expression. So log 7 plus log x. There's nothing more I can do there. This one would become 3 ln x minus ln 4. Of course, you could also probably have it like this. Okay. Oh, something's coming. Something's coming. Something coming.
Grant.
Oh, yeah. He's here. Does he need to be escorted? Let's see what they
I
say.
didn't read it. Read it out loud.
Bro, this kid misses every day. Obviously, he's gonna
It
do
says that you're. It says somebody.
Minor green. I already got 2.
From your mom, man.
All right. Let's expand this one. So log 3 squared plus log b plus log c to the third. Let's bring the exponents down. Log base 3 of 3, that's just going to be 1 plus log b plus 3 log c. So that's going to just give me 1, so I get 2 plus log b plus 3 log c. We good? Wait a sec. Blessing you.
Thank you.
And then everything, the 4x is all under the third root, so I'm going to get 4 to the 1/3 and x to the 1/3. Do you agree with that? Okay. So this right here is going to become 4 to the 1/3 and x to the 1/3. So if we expand it, I'm going to get 1/3 log 4. I guess I can make that 2 squared. So I could then make that 2/3 log 2. That would work. Okay, so I just cancel that out. And then plus 1/3 log x. And then 10 squared. So I'm going to go minus log of 10 squared what we have to recognize is that right there is 1, so it brings the exponent down. So my answer becomes 2/3 log 2 plus 1/3 log x minus 2. There's my answer.
Nice.
Someone just run past my foot?
I saw a mouse on somebody's story this morning.
Nice. No
Snapchat.
way.
I didn't see anything else.
It was a white mouse. It was like Stuart Little.
All right, condense. So because it's subtraction, this exponent can come up top. This is going to give me log 5, x over 2. It's an x. I could put it in parentheses if I wanted to, so I know I'm doing the log of the whole thing. It's not totally necessary. Recognize that this is 3 squared, so this is going to become minus 2, right? Because I get log base 3 of 3. So I'm going to condense this. I'm going to get
Log base 3.
so log base 3 of c to the third plus or d, and then the whole thing is just going to be over just going to be over 2. There we go. So the only part that's a log is this is the only part that's log. It's over 2. I'm sorry, cut off the 2. That poor little guy.
Wait, how do you get 2? Oh, because negative 2.
Mm-hmm.
This is our last slide, by the way.
Yay. Let's see. This, condensing it. So I'm going to get ln third root of 5x over y. I guess I could put that whole thing in parentheses. That worked out nicely.
Minus
Everyone good with that?
That starts to make sense. That's kind of.
Starting to go? Uh-oh. Starting to do my job, I guess. And then this is going to give me ln x squared. If I bring that as an exponent, that's going to be the third root of y squared all over x to the 5th. I guess I could reduce the x's at this point. So I'm going to get ln third root of y squared over tug of war, bottom wins by 3. There's my answer. We good?
Wait. Oh, because it's 3, so y squared doesn't come out.
Yep, and that was it?
Yeah.
Sweet. All right, so let's do this.
Orange squared?
Let's make sure for tomorrow, worksheet J is done. And we'll go over questions on that tomorrow. And then by Friday, we will say that worksheet K is due. But it'd be good for you to review because on Thursday, this is the review for Thursdays. Okay. I know. I'm tentatively, things would adjust if needed. All right.
We should just get an A on the test.